This is an example of a basic table view. To begin, I'm going to create a repository on GitHub for my project, which I'm going to call Foods. The table view is going to display a list of foods, so we're going to also call the project Foods. This is a public repository. I'm going to initialize it with a README, and I'm going to add a gitignore for Swift. No license. I'm going to create the repository, and then I'm going to take my gitignore and edit it, as I typically do, to add to the other section .dsstore to be ignored. So I added .ds_store, and I'm going to say here in the commit that .dsstore was added to gitignore. I'm going to commit this directly to the master branch, and this gives me my starting repository for my project, so I'm going to copy the URL for cloning it. Then back on my computer, I have opened up the terminal, and I'm going to navigate to where I hold my projects. And here I'm going to clone the repository. So I'm going to say git clone and that URL. So now we have a directory called Foods with a README in it. It also has the .git and .gitignore. So we are ready to begin the project. I'm going to launch Xcode. I'm going to say I want to create a new project that is an iOS single view application whose name is Foods and is going to be done in Swift as a universal application. I'm going to find my Foods directory that was created when I cloned my GitHub repository, and I'm going to create my project in that directory. Now, when iOS creates a single view application, on the storyboard, they give a starting view controller. And if this view controller is selected, we see that it is set as the initial view controller. That's a result of this arrow right here. And this view controller is given a custom class that's called view controller. And this custom class is this file right here. Now, we actually want to delete the view controller file because a name that is as generic as view controller is really particularly useful to us. We need a name that is more specific and that describes what we're doing. So we're ultimately going to create a view controller called FoodsViewController. So to begin with, I'm going to delete this because it is too generic for us to use it. So I'm going to move that to the trash. That file is now gone. This view controller in Interface Builder still points to that class that was in the file that I threw away. We're going to have to change this, but first I'm going to create the file. So I'm going to click on Foods folder inside the Foods project. Hold down the Control key and click and say New File. And what I'm going to want to create is an iOS Cocoa Touch class file. So I'll hit Next. And I want this file I'm creating to be a subclass of UI View Controller. And it's already set to be that. But let's say it isn't. I come here and I have something else as my subclass. Then I'm going to want to start typing that or go to the drop down and select it from there. So I'm going to make a subclass of UI View Controller, and I'm going to call this, specific to our task, Foods View Controller. And this is going to be in the language Swift. So hit Next. I should be in my project folder beside my other files. appdelegate.swift should be in my list. So that is where this view controller is going to be created. So I click Create, and now I have a Foods View Controller that is a subclass of UI View Controller. This, by the way, can be dragged around. That doesn't change where it is located inside the project directory. So we have our FoodsViewController. If I go back to the storyboard and I select the view controller, under custom class, I now want to set this to FoodsViewController. So now this view controller has the custom class of FoodsViewController, so this is the code behind that interface. Now let's say for a moment, and I know we haven't gotten to tables yet, but let's say for a moment you deleted this view controller and you in fact started with a blank storyboard. This isn't a problem. What we can do is go find a view controller in our library, drag it out and drop it. And just like we did a moment ago, this view controller is going to use the custom class FoodsViewController. So I'm going to type FoodsViewController here and hit enter. And we're almost done. To get it back to the way we had it before, this has to be the initial view controller. So with it selected, I go up here to the attributes inspector and I click is initial view controller. That makes the arrow appear, and that means this is the entry point, starting point for our storyboard. This is where the user experience begins. So we have our containing view controller and we have our associated custom class FoodsViewController. Now we're going to begin laying out our UI for the table view. So in the library, search for table view, and be careful, we don't want the table view controller, we want the UI element table view, and drag it out and drop it wherever you want inside the view controller. Now a table view can be a subset of an overall user interface. It could be just part of the elements that are listed in a UI. But for this example, we're going to make the table view the full UI. And that is often done as well, that when you open an app and you see a list of things, you're looking at a table view that occupies the entire user interface. So with the table view selected, the easiest way to add the constraints is come down here to add new constraints. Uncheck constrained to margins because I want my table view to go all the way to the left and right edges, not stop at the margins, but go all the way to the edge of the super view. And then I'm going to click the 4 lines to indicate I'm going to put constraints on all 4 sides, and I'm going to put 0 in for each of the numbers. This will be 0 points down from the top layout guide, 0 points up from the bottom layout guide, and then 0 points from the view. And since there aren't any constrained margins, this is 0 to the super view, 0 to the super view on the left and right side, or the leading and trailing sides. So I'm going to say add 4 constraints, and the table view now fills my user interface except for the status bar at the top. Now my table view contains table view cells, and the way that we're going to program this is we're going to have a cell that is going to serve as our design, and that's called a prototype cell. So with the table view selected and with attributes inspector selected, there is an entry under table view that says prototype cells, and if you increase this to 1, a prototype cell appears. And if you go here, by the way, if you can't see that, remember this icon can be used to open and close this segment. Inside the table view is a table view cell. And this will be something that we dequeue, that we get a instance of in the code from the table view, and then we will put information in this cell. So we're going to have to make some choices for this cell. The first is the style of the cell. The default is custom, which is we would do the layout of the elements in the cell. There are some predefined layouts, and here they are: basic, right detail, left detail, and subtitle. For this example, we're going to choose a basic style, and that essentially gives us one label that is inside the cell where we can put information. So this cell is a basic cell, and the other thing we need to do is give it a reuse identifier. When we dequeue this cell, we're going to dequeue it from the table view, that is, get a copy of it based on its reuse identifier. And since I'm going to be putting names of foods in the cells, I'm going to call this food cell. And I make the first letter lowercase f, and then the C in cell uppercase. This is camel cased, and it's not required. Some people use underscores between the parts, some keep it all lowercase. But I choose to use identifiers that are camel case. So I'm going to need to remember this, or later come back and look for it, but the reuse identifier for this cell is food cell. So we have a cell that's a basic cell, and it's identified by food cell, and it's a cell that is a prototype cell contained in the table view. It's within the hierarchy of the view here. These prototype cells, in order for them to appear, we're going to have to create instances based on them, and then tell them where to be in the table view. One more thing before we leave here. There is the question of, how does the table view get the information that tells it how many sections it has, how many cells in each section it has, and what each of those cells look like, and what should happen when a cell gets tapped on. And the way table views work with iOS here in Xcode and Swift is that the table view needs something, an object that serves as a delegate and a data source to answer these questions. So we are going to use our FoodsViewController as our data source and delegate for the table view. And one step in doing this is to tell the table view what its delegate and data source are. And the first way to do that I'm going to show you is here in Interface Builder. And the way I can set the delegate and data source is by selecting the table view, holding the Control key down, and then click drag from it to the view controller, the FoodsViewController, and leave up. And it says here outlets, data source and delegate. There are no dots beside either of these, so neither of these are selected as the data source or delegate for the table view. So I'm going to make the first selection and click data source. Now if I control click on here, you can see data source is connected to the table view. So this FoodsViewController is serving as the data source for the table view. And all this means is the instance of the FoodsViewController, this object, is going to have methods that the table view can call on this object, an instance of the FoodsViewController, to answer certain questions. So we have the data source set. Now we also need to set the delegate. So I'm going to select the table view, hold the Control key down, Control click, drag to the FoodsViewController, leave up. You notice the dot beside data source indicating the data source is already set. We're going to click on delegate, and it is also set. And just as a different way to check, rather than Control click here and looking for data source and delegate, I'm going to Control click drag to here, and we can see there are two dots set indicating the table view has the FoodsViewController as its data source and delegate. The alternative to doing this is setting the data source and delegate in code, and I'm also going to show you that a bit later. So now that we have our table view placed and we have our FoodsViewController set as the delegate and data source, we now need to do some coding. In order for the FoodsViewController to serve as the delegate and data source, it has to follow some protocols that specify the methods that we can implement to be a data source or a delegate for the table view. And right now, FoodsViewController is a subclass of UIViewController. And the colon here is used to separate the subclass from the superclass. If we have a superclass, we list it first, and then after it, we can put comma, and we can list the protocols that we want to adhere to. So the first one is UI Table View Delegate, and the second one is UI Table View Data Source. And when I do that, I get this red exclamation point because we're being told that FoodsViewController currently does not conform to the protocol, and then it lists the protocol that we're not conforming to. So we've specified two protocols that we want to conform to, but we haven't written the methods yet or provided the other pieces of information that are needed to conform to the protocol. That's coming. But in order for us to write those methods, we first want to list the protocols, because then we have the ability to use code completion to tell us really what methods we need to write. So I know that one of the methods that I need to write is number of sections in table view. And all I had to do was type NU, and it provided me with a list of things that I might want to put here, the first of which being number of sections, because I am following a protocol that says number of sections is in that protocol. So if I hit enter, it will literally write the function for me, and all I have to do is enter the code that is to execute when that function is called. So number of sections is a function that gets called by the table view when it wants to know how many sections the table view has. And a section is a collection of cells. If you had a contacts app, A would be a section, B would be a section, C would be a section. So the idea is that a grouping of cells can be put in a section, and there can be more than one section. So the basic format, basic layout for a table view is a table view has sections, and then each section has rows. And the question we're answering here is, how many sections does this table view have? Well, we're going to just list one list of foods in one section, so I'm going to return 1 because I'm going to have one section in this table view. Now the next question that I need to answer is, for each section, how many rows are there in a given section? And since we only have one section, we're only going to be asked about that one section. All the rest of the methods that we need to implement are going to be table view functions, table view methods. If I start typing table, we see here a rather lengthy list of methods, that is functions, that all begin with table view and do various things relative to the table view. In fact, one of the one that I was alluding to here a moment ago, which is how many rows are there in a section, is in table view, number of rows in section. So I'm going to select that, and we have here that when this gets called, it's going to provide us with the table view in question. So that's a parameter we're going to receive. And we're also going to receive the section in question. So as the table view is being built, it's going to ask how many sections, and we're going to return here 1. And so then for that one section, it's going to call table view with the table view, and it's going to supply the section. And for that section, we need to answer the question, how many rows are there? And so we're going to return an int. So we want to be able to say here, return and some number. But we don't know what number because we have no idea yet where our data is coming from that's going in this table view. So let's go back to the top of our FoodsViewController class, inside the class but outside of all of the functions. We're going to create an array, and the array is going to hold a list of foods. So we're going to say var foods equals, and we're just going to build an array in place of strings. And the foods are going to be pizza, followed by sushi, followed by steak, and chicken, and fruit, salad, and cake. So we have an array of foods that is going to be instantiated when the FoodsViewController class is instantiated into an object. So when this object is created, this variable is a property of this class. So this will be instantiated, this property, to foods, and it will be an array of these foods. So down here where we're answering the question, how many rows are in the section? And so we're being handed the section. If there were multiple sections, we might have to check which section we're in to answer how many rows in that section. But we're going to ignore the section we're being handed because we know right now we only have one section. So this is only going to get called once for section 1, and we have to answer for section 1, what is the count of the number of foods that are going to get displayed? How many rows are in this section? So we're going to say return, and we're going to get the number of rows in the table to be equal to the number of items in the foods array. So we're going to say return foods dot count. The count is the count of the number of items in the foods array, and that is the number of rows in our one section. The next thing is we need to specify what a cell looks like for each row in each section. And this begins also with table view and happens to be the first item. Table view cell for row at index path. I'm going to show you another way to get to this. I don't have to type table view first. I could say I'm thinking about the need to create cells. So I type cell and I get cell for row at index path. And I hit enter, and this function, table view cell for row at index path, is going to get called for every row in every section. And what I have to return here is a UI table view cell. So we need a cell. And as I mentioned when we were creating the cell, that we're going to dequeue the cell, that is, get a cell from the table view based on the design. Let me go back to the storyboard. So we have here the table view. Inside the table view is this food cell. Food cell is the identifier. It's a basic cell. It looks like this. This prototype cell, we're going to dequeue one of these, and then we're going to use it to fill in the information for the cell and then return that cell, and it will be our UI table view cell. So we can say let cell equal table view dot, and we're going to type DE to get down to dequeue reusable cell. And we have a two options here. One is dequeue reusable cell with identifier for index path. The other is just with identifier. We're going to be handed an index path, so we're going to use the version that dequeues a cell with an identifier and based on an index path. So I'm going to hit enter. So we're going to get the cell by getting it from the table view based on the identifier, and the identifier I had created was food cell. That is the same identifier that is the name that appears here and is the identifier that was placed here. And I'm going to delete that identifier. Behind it, it says reuse identifier. And that's what this is a reuse identifier. And we're calling it food cell. It's a reuse identifier because cells that scroll off the bottom that aren't in use anymore because they aren't being looked at can be reused for cells that the user is seeing or that are just off screen. This is serving as an object pool, and we're requesting an object from the object pool. And objects that are in use are not available in the pool, and then when a cell's no longer needed because the system's decided cell's no longer needed, it puts it in the reuse pool. And so our dequeuing a reusable cell is not really something we have to concern ourselves with and how it manages them, but is requesting a cell from a pool of cells based on the identifier, and which we called food cell. And the index path is the index path that we're being passed into this function. So we're just going to pass it along to the dequeue reusable cell. So we're saying we want to get a cell from the table view with this identifier for this index path. So now I have a cell, and ultimately I want to return this cell. And this cell is of type UI table view cell. And if I hold the Option key down and click on dequeue reusable cell, we will see that dequeue reusable cell returns a UI table view cell. So what this returns is what this function wants us to return, which is what we're doing. Now, the cell has properties, and one of those properties is text label. And that is that title that appeared in the cell when we said we wanted basic cell design. This text label is in fact a label, and it has a text property. So we could say that the text property of the text label is going to be set to the name of our food, which we're going to pull from the foods array. So we're going to index into one of the items in the array, and that is going to be based on the row in the section we're in. We are being given a thing called an index path. And an index path has some properties. One of them is row. Another of them is section. So we can get the section from the index path to say what section is this cell in, and then we can also get the row from the index path. Now we're going to just use row because we can ignore what section we're in for right now because we only have one section. We only have one list of foods that are going to appear in one section. So we only need to know from the index path what the row is. So indexPath.row is the row in the table view. That corresponds also to the row in the foods array. So whatever food is going to be assigned to the text of the text label, the cell is going to be returned, and the table view will display that cell. And the table view knows to use this FoodsViewController as its delegate and data source so that these methods can be called on this object by the table view to answer the questions: number of sections, number of rows in section, and what does the cell look like for a particular row and section. Based on this view controller being set up as the data source and delegate for the table view. So the instance of the table view, when it needs to have a question answered, will go check what its delegate or data source is, which happens to be this FoodsViewController, and then on that view controller it will call these methods that I just wrote to answer the questions: number of sections, number of rows in section, and what a cell looks like. Now we're almost done. We're missing one thing because we have this little error appearing, and it says value of optional type UI label, not unwrapped. Did you mean to use exclamation point or question mark? And then it says fix it, insert question mark. Text labels and optional. It is possible that this optional, I'm going to hold my control key down and click here. So there isn't any, I was looking to see if we had any quick help there, but we don't at this point. We do not have it there either. So text label, which we were told by this error, is a UI label question mark. It's an optional. So it's possible that text label is nil. And if it's nil and we try to access the text property on it, then we're going to crash the program. So text label needs to be unwrapped before the text property can be called on it. And it should be safely unwrapped. It should deal with the situation that, hey, maybe it's nil. And one way to do this is using optional chaining. By putting a question mark here, we are saying, hey, check to see if text label has a value, and if it does have a value, unwrap it, and then call .text on it. If text label contains a nil, then the execution of this line of code stops. If text label, again, contains a value, then it would get unwrapped, and we're able to call the property .text on it and set it equal to the particular food. Now let's see how this operates. So I'm going to run the simulator. And we get our list of foods: pizza, sushi, steak, chicken, fruit, salad, and cake. And right now when we select them, it highlights the cell, it selects the cell, but we don't go anywhere. Navigation is coming up next, and we'll learn how, when a cell is selected, we can navigate to another view controller and display some information. If we rotate this right, the table view displays correctly in the device, and if we rotate back to left again, it displays correctly there. Now, I mentioned multiple times that the table view knows what to display based on the delegate and data source for the table view. And the delegate and data source is this FoodsViewController. And back in the storyboard, we had a way of specifying that the table view uses the FoodsViewController as its data source and delegate. And we did that by control-click dragging from the table view up to the view controller and selecting data source and delegate. I'm going to remove the data source and delegate entries, the referencing outlets. So the table view no longer sees the FoodsViewController as its data source and delegate. And if we run the simulator again, we will see what happens. And what will happen is that the table view will display nothing because it has no delegate and data source telling it how many sections, how many rows in that section, and what does the cell look like. I mentioned previously also that there was another way, an additional way of setting the data source and delegate. And one way of doing that is in the FoodsViewController. If we have access to the table view, we can use the table view object to set the delegate and data source to be an instance of this object. And right now, in the FoodsViewController, we do not generally have access to the table view. And one way we could get access to the table view is by creating an IB outlet. So I'm going back to the storyboard, selecting the table view, opening up the assistant editor. We should get the FoodsViewController being displayed because that's the currently selected view controller. And we're going to control-click drag from the table view into the FoodsViewController, leave up, and we're going to create an outlet to the table view. I'm just going to call it my Foods table view, beginning with a lowercase F because properties should begin with lowercase letters and be camel case. And now we have an IB outlet to our foods table view. I'm going to go back to the FoodsViewController, and down in View Did Load, I'm going to say foods table view dot data source equals, so we're saying to the foods table view, your data source, which is a property of foods table view, is going to be this object, the object that I'm in, and the keyword in Swift for referencing an instance of an object from within the class is self. So we're saying this object is going to serve as the data source for the foods table view. And then I'm also going to put foods table view dot delegate, and this object is also going to serve as the delegate. So the foods table view has a delegate and data source that are being set in View Did Load. So if I now run it, I should be back to having a list of foods. It doesn't really matter whether you set the delegate and data source in code. To do that, of course, though, you need access to the table view. You can also do it, remember, here by control-click dragging and setting it in Interface Builder. So those are the two options. Set the delegate and data source in the table view, or set the delegate and data source here in the code. One last thing before we go, there are other properties on the cell. One I'd like to show you is called background color. And for each cell, you could set the background color. You could vary the background color. For right now, I'm going to set the background color to one particular color, let's say green. So I'm going to get that color from the UI color class, and I'm going to choose green. This is a predefined color on UI color, and I'm saying that the cell's background color should be this particular color. So when I run this again, each of the cells where we created a cell, we set it equal to green. That might be helpful for the extra part of the challenge that you have to do for this module. Before I'm finished, I need to make sure I've committed my work to my Git repository and then pushed it to GitHub. So I'm going up to source control. I'm going to select commit. I'm going to enter a commit message. Implemented a table view that displays a list of foods. I'm also, in addition to committing it, going to push to GitHub. And if I go back to GitHub to my foods repository, we will see that the work we did is now on GitHub.